Hello learners, I'm Akash. I completed my BTech from NIT Rourkela in the year 2020. Currently I'm a mathematics teacher. Now let's see how to solve this given question. Here we have to state and prove Bayes theorem on probability. Trust me guys, this is going to be a little tough to understand. Even for me it was a little tough to understand, so I can understand that it could be a little tough for you to understand, but still try your best to understand. Okay. Fine. So first of all, I expect you to mug up the theorem. Okay, if you'll remember the theorem statement nicely, from there I can explain to you how it works and how it is going. Fine. Now let's get started. As per Bayes theorem, suppose E1, E2 and so on till En are n mutually exclusive and exhaustive events of a random experiment with P of Ei not equal to 0 for I equal to 1, 2 and so on till n. Then for any event A of the random experiment with P of A not equal to 0, then P of Ek given A, P of Ek by A, sometimes we call it, is this. I know you did not understand anything. Let me go slowly, step by step, so that you guys can understand what is happening over here. Now see carefully, listen. I'm going to go very slow, so this video could be a bit long. Even though the theorem is short, the explanation takes time. So if you are someone who just wants to mug up, it's okay. But if you are someone who seriously wants to understand this theorem, so please listen to this carefully. Okay. Now see, before we start this theorem, I want you guys to know something. P of A given B, or P of A by B sometimes we call, is nothing but P of A intersection B by P of B. This is something we'll be using a lot. P of A by B is nothing but P of A intersection B by P of B. Now this is also called as happening of A after happening of B. That means first B has happened, after that what is the probability that A will happen. Okay, P of A by B, that's what it means. But in general, I'll keep it simple. P of A by B is P of A intersection B by P of B. This is something you can remember. This is from conditional probability. Okay, this is from conditional probability. Fine. Now one more thing we can analyze here. If you'll send P of B here, if you'll send P of B here, so what you'll get is P of B into P of A given B, or P of A by B, is nothing but P of A intersection B. So P of A intersection B is nothing but P of B into P of A by B. I just sent P of B over here. This is one of the things which you are expected to know if you want to solve this prove this Bayes theorem. Fine. Now as I already mentioned, you are supposed to remember this theorem word to word. It carries around 1.5 to 2 marks. Okay, if you write it as it is also, you could get 1.5 to 2 marks. Fine. Now let me go step by step. Suppose E1, E2, E and so on up till En are n mutually exclusive and exhaustive events. Fine. E1 and E1, E2, they are all events. Okay, till En there are n events. You can see, right, 1, 2 and so on till n. So there are n events present. Okay, let's say there are n events. Fine. In a random experiment there are n events, and P of Ei is not equal to 0. What does it mean? Probability that an event will occur is not 0. That means what? Probability that means generally every event has some probability. Okay, every event has some probability of happening. In general, probability is always greater than 0. Okay, in general probability is greater than or equal to 0, but now they are told that probability is not equal to 0. That means probability of an event happening is greater than 0, which I'll write later. Okay, probability of Ei is greater than 0. Fine. Now then for any event A of the random experiment, okay, some event is there, some event A of the random experiment, okay, and P of A is not equal to 0, the probability of that event happening is also is not 0. Then P of Ek by A, what does this mean is probability of Ek, okay, event Ek given A. That means what? A has occurred, after that what is the after that, like let's say A has occurred, then probability of ek given A is nothing but probability of event ek occurring into probability of A given ek. That means what, ek has occurred, then A is happening. So probability of A given probability of A given ek by sigma I runs from 1 to n P of ei into P of A by ei. Okay, fine. Chalo. Now it is given that P of ei is greater than 0 for I equal to 1. Now the proof has started. See, they have given us, see the order in which I am writing. They have told us that P of ei is not equal to 0. They have told us that P of ei is not equal to 0. That I already mentioned. That means what, probability is definitely going to be greater than 0. Probability of every event is greater than 0 for I equal to 1, 2 and so on up till n. Now what does this n exclusive events mean? Exclusive events means even intersection E2 is phi. Okay, exclusive events means, like let's say A and B are exclusive events, mutually exclusive events. That means what, A intersection B is a null set. A intersection B is a null set. Okay. Now here what did they mention? They mentioned that E1, E2 and so on till En are n mutually exclusive events. That means what, if you will take intersection amongst any two events like E1 intersection E2 or E1 intersection E3 or E2 intersection E4, that is null set. So for I not equal to j, ei intersection ej is phi. So this line mutually exclusive. See, from this line, from this point, I got the first statement. Okay, probability from this point mutually exclusive. I am getting my second line. Next, from this point exhaustive. From this point exhaustive. This is my third point. Exhaustive means what? Exhaustive means union of all these events gives me sample space. Union of all these events gives me sample space. Sample space is what, it contains all the possible things that can, all the possible outcomes of the random experiment. Okay. Now exhaustive events means union I runs from 1 to n ei is nothing but S. This means what, E1 union, if I were to write it for your understanding, this actually means E1 union E2 union E3 and so on union En is nothing but S. Union of all the events is S. This is what exhaustive events refers to. Now next, let's get started. This is the, see, till now I used whatever was given. Now from here on we are going to do something else. What is that? See, S is the sample space of the experiment. I already told you. Now see, listen carefully, listen carefully. S is what? Sample space. Sample space contains all the possible outcomes of an experiment. Now any event A will have some outcomes. Any event A will have some outcomes of the experiment. A will have, the event A will have some outcomes of the experiment, but S will have all the outcomes of the experiment. That means what? A is subset of S. A is subset of S for any event A. Okay. Next, in general, since A is subset for any event A, what we have is, listen carefully. This is a little tough. Okay, before what I'm going to write now is, see, what you'll see next is A is nothing but A intersection S. Now what does this line mean? What does this line mean? See, S is what? S contains all the possible outcomes. Now A contains some outcomes. A is an event in which will have some outcomes. Now all outcomes intersection, now some outcomes intersection all outcomes will give me the same, some outcomes. Listen carefully. Some outcomes. A is some outcomes. Intersection S is all outcomes. Some outcomes intersection all outcomes will give me some outcomes only. So A can be written as A intersection S. Next. Now S is what? S is what? Here I told, right? Union I runs from 1 to n ei is nothing but S. Now union I runs from 1 to n ei. Next, listen carefully. Now this can be written as A intersection union I told you right, this one already. This is nothing but maybe I'll just put it again. This is nothing but E1 union, E2 union, E3 union, and so on till En. Now, so A intersection of this is nothing but, this can be written as A intersection of this can be written as union of I runs from 1 to n, A intersection Ei. Okay, that means A intersection of union of all these events, we can write it as A intersection E1 union A intersection E2 union A intersection E3. Fine, that is something which we can write. This step, if I'll explain it, it'll become even more deep. So for now, you can just understand it like A intersection. This can be like A intersection EI union of I runs from 1 to n. Okay. Already this video could be a little long. If I'll explain this also, this could go too long. Fine. Now next. So A can be written like this. Now listen carefully. What I have here. A intersection EI. What I have here is A intersection EI. Let's say there are two events, okay, EI and EJ. Let's say consider A intersection EI and A intersection. Okay, before that, there is one concept which you guys need to know. See, if A intersection B is null set, that means probability of A intersection B is 0. Probability of A intersection B is 0 because A intersection B is null set. It's an empty set, right? So probability of that happening is 0. Now P of A union B is nothing but P of A union B by addition theorem of probability. P of A plus P of B minus P of A intersection B. But if A and B are mutually exclusive events, like A intersection B is null set, that means P of A intersection B is 0. So this is going to be P of A plus P of B. That means what? Whenever A and B are mutually exclusive events, P of A union B is P of A plus P of B. Now listen carefully. What does this mean? Is this basically means that A intersection E1 union A intersection E2, sorry for the bad handwriting, union A intersection E3 and so on, union A intersection En. I hope it's clear. Maybe my video is coming a little in the way. I'll try to write it here again. See, this is nothing but A intersection E1 union A intersection E2 and so on, union A intersection En. I know you might be thinking, what is this? Like, so much of understanding. Yes, so much of understanding is there. Now see, A intersection EI means like this union I runs from 1 to n, that expansion I just wrote. So this is what A intersection EI union A intersection E2 union this one. Okay, so I'm sorry, A intersection E1 union A intersection E2 until so on till A intersection En. Fine. That means what? If I'll take any two, so I have basically intersections and their union. Okay, I have intersection and their union. Fine. Now listen. Consider this. A intersection EI intersection A intersection EJ. Like here you have, right, A intersection E1, A intersection E2, A intersection E3. So I'm taking any two random things, okay, EI and EJ. So A intersection EI intersection A intersection EJ is nothing but A intersection of EI intersection EJ. Now remember carefully, in the beginning of the theorem, our events are mutually exclusive. That means what? EI intersection EJ is null set. I wrote it here, right? See, EI intersection EJ is null set. Now A intersection null set is null set. That means what? Intersection of two events is null set. Whenever this is actually not just two events, like this is actually all the events, like A intersection E1 intersection A intersection E2 and then A intersection E3, that also will be 0. Now if you'll use the concept, P of A intersection B is 0 means P of A union B is P of A plus P of B. So P of A is nothing but sum of probabilities of P of A intersection EI. Why did this happen? This happened, I told, right, logic is simple. P of A union B is P of A plus P of B when A and B are mutually exclusive. But here A intersection EI, A intersection E1, A intersection E2, A intersection E3, A intersection En all are mutually exclusive. So what? So probability of A is nothing but probability of this, right? Probability of A, listen carefully, probability of A is nothing but probability of this. Now this, the probability of this is going to be what? These are all mutually exclusive events. So my probability is nothing but probability of A. Listen carefully. Probability of A is going to be probability of A intersection E1 plus probability of A intersection E2 plus probability of A intersection E3 and so on till probability of A intersection En. I know you guys did not understand, could not have understood this point at all. If you did not understand it, then just mug up. Like, I am telling you whatever I understood to whatever extent. But the logic is this only. Once again, I'm telling. See, whenever A intersection B is null set, that means probability of A intersection B is 0. P of A union B is going to be P of A plus B of B. This is what union of all this. This is what union of all this. Now P of A is nothing but P of this. P of A intersection E1 union. Now we know that these are all mutually exclusive. That means what? My probability is going to be probability of this plus probability of this plus probability of this and so on. That's what I wrote. I hope it's making some sense. This we can write it as sigma I runs from 1 to n P of A intersection, like E1, E2, E3 and so on till En it's there, right? So this we can write it as sigma I runs from 1 to n P of A intersection Ei. Now next, listen carefully. Listen carefully. This I can write it as P of Ei into P of A by Ei. This I can write it as P of Ei into P of A by Ei. I already told you P of A by Ei is nothing but P of A by Ei. See, P of A by Ei is nothing but P of A intersection Ei by P of Ei. Now if you'll send P of Ei here, so this I'll erase it. This doesn't come well, yeah. So P of A intersection Ei is P of Ei into P of A by Ei. This I already mentioned in the beginning, like P of A by B is P of A intersection B by P of B. Fine, I know you guys could not have gotten anything, but still I'm trying my best to give you some logic so that you don't have to mug up. At the end of the video, I'll tell you a technique to mug up also, okay? At the end of the video, I'll tell you a technique to mug up also. In case if you feel, sir, maku asalu em ardham kaledante, sare andi batti kottadaniki technique cheptanu, okay na? Fine. I'll tell you. So this is my multiplication theorem of probability. This is what we wrote. Fine. Now next, by multiplication theorem of probability. See, in the theorem what they are asking us. In the theorem what they are asking us. They are asking P of Ek by A. P of Ek by A is going to be, as per multiplication theorem of probability, in general, this is going to be P of Ek intersection A by P of A. This is what, right? I told you P of A by B is nothing but P of A intersection B by P of B. So P of Ek by A is nothing but P of Ek intersection A by P of A. Fine. Now P of A we already know. P of A is this, sigma I runs from 1 to n P of Ei into P of A by Ei. So this is what you get. Now again something else you guys need to know. See, I'm sorry that there is so much of explanation in this. So in exam you don't have to write all the explanation, you only have to write whatever is there on the PPT, like what I did not write using red. But still we forget, right? So to understand we need to have a logic. See, here P of Ek by A is there. I want P of A by Ek. P of A by Ek. P of A by Ek is nothing but P of A intersection Ek by P of Ek. So P of A intersection Ek, P of A intersection Ek is going to be P of A intersection Ek is going to be P of Ek, send this here, P of Ek into P of A by Ek, P of Ek into P of A by Ek. Fine. So numerator is going to be P of Ek into P of A by Ek, and P of A already told you. P of A is sigma I runs from 1 to n, P of Ei into P of A by Ei. That's it. This is what you had to prove in Bayes theorem, and we proved it. I told you some logic that I understood. I know I could be a little wrong here and there, but still I tried my best to give you the logic by which the theorem actually happens. Fine. In case you did not understand, watch the video two or three times. If you feel sir maku asalu ardhame avatledu ante, you can just tell me in the comments. You can join my WhatsApp group, and I conduct regular live classes in on Zoom, so you can join that and ask what you did not understand. In case if you are serious, now I'll tell you the technique to mug up. I'll tell you the technique to mug up. See how to mug it up. Sir మేము ఎలా మాకు ఇది ఏం అర్థం కాలేదు సార్, ఒక్క ముక్క కూడా అర్థం కాలేదు. See, first thing I told you, you should know this statement. Let's say you mugged up this statement. Now once you mug up the statement, see, probability P of Ei is greater than 0 because P of Ei is not equal to 0. That is simple. First point, this you can write. Next, mutually exclusive means I told you Ei intersection Ej is null set. This you have to remember. Mutually exclusive definition, it comes. Exhaustive means this. Fine. Union I runs from 1 to n, Ei is S. Now next, this is one step you have to mug up. This is one step. S is, see, these two statements you know, right? See, here S is coming, here S is coming. What is S? You have to write about it. See the logic in which I'm telling. First mug this up, then first statement comes from this, then mutually exclusive means this you will get, mutual exhaustive means this is what you'll get. Next, S means what? S. Now here you got S, here you got S. What is S? You have to write about S. I'm telling you how you can mug it up, the logic to mug up. S is sample space. Now next, A is nothing but A intersection S. This is another thing you have to mug up. S is what? S here we already know. Union Ei. I runs from 1 to n Ei. Now this A intersection union you can write as union of A intersection Ei. Simple logic, right? You don't have to, and you can just mug this up. Now next, here you get A intersection E, right? Now here I and J, you have to take two things. For I not equal to J, A intersection E, I intersection A intersection EJ. So this only comes again, but J. Now A intersection EI intersection A intersection EJ, simple logic. This you can write it as A intersection EI intersection EJ. This is null set, so this is null set. So ultimately probability of A is nothing but sigma I runs from 1 to n P of A intersection EI. This you just, in place of union you put a sigma, and then here you will get a P of A, here also a P, a technique to mug up. Now after this, let's say you come till here. See, you can see this, you don't have to, if you will mug up this statement and you see here what you have, sigma I runs from 1 to n P of Ei into P of A by there ascend. Okay, just write that same thing. So that's what you'll get. Fine. And in the bracket you can just mention multiplication theorem of probability from intersection, how it became Ei into P of A by A. Now next, what you have to prove? You have to find out P of Ek by A, right? P of Ek by A is nothing but P of Ek intersection A by P of A. That's something you already know. Now after this step, what you can do is you can directly write down what is there in the theorem. After this step, you can directly write down this theorem. K runs from 1 to, directly write down. Fine. A technique to mug up, as I mentioned, I told you I'll tell you a technique to mug it up also to some extent. So this is some logic to mug up so that you won't forget it. Still guys, I tried my best, I can tell you, regarding explaining Bayes theorem to whatever level I could. Here and there could be some mistakes, so I'm sorry if there are any mistakes. I'm apologizing. If I made any mistakes, please tell me in the comments box, but to my knowledge I gave you what is right only. Fine. And as I mentioned, if you have any doubts, you can tell in the comments box. If it is a lengthy doubt which I cannot explain on comments, you can join. I'll give you the link to my WhatsApp group, or you can go to my channel. In the beginning of the channel, the introductory video only, you will find out the free intermax class, like that link and all. Join the WhatsApp group and come to my live class. You can ask the doubt. Okay, I hope I didn't bore you too much, and if you did not understand anything, I'm sorry. I tried my best, but still if you could not understand, I'm sorry. I may not be a good teacher. I still need to level up. Maybe in future, if I get a better way of explaining the theorem, I'll come back with that. Anyways, I'll try to come back with a better way if I get it. Thank you.